Okay, everybody. So here's kind of where we're at. And here's where we're going. Okay, let's put cell phones and other things away if we're going to jump into today's lesson. Pull out your notepad if you don't have it out yet. Okay, so last time we learned how to write the formula given a name for an ionic compound. Today we're going to learn the reverse. So if I give you a formula, can you write its name? On Friday, we're going to learn how to do covalent naming, because these are all just been ionic. Next Tuesday is our review, and then we're going to do an at-home test next Wednesday. We're doing an at-home test just because of the Wednesday thing, we've lost, like 6 days of this term. And so that's kind of one way we figured we could make up time, is a test at home is not too hard to do. And you don't need, I can't help you on the test anyway. So I'll give you instructions of how that works. Oh, my box.
Oh my God.
Okay, one other thing just to kind of make note of, and I love that this keeps happening with B-Days, but B-Day is a minimal day, if you didn't know.
A minimal day?
So it's kind of like the length of the days at like the last day of the term. It's one of those again.
Our days are already short, and then they cut it in.
What the heck? Might as well just not go. I mean,
Fridays are always going to be like that, or just this
No, just this Friday. So I don't know for sure. From what I understand, it has something to do with the fact of, we always get a short day like on the last day of the term.
yeah.
Which is super helpful like for teachers, because then I have like more time to get stuff finalized and not have to do it at my house. The elementary schools are on a trimester instead of 4 terms, and theirs ends today. And for whatever reason, the high schools we all have to be the same. And so since they're doing a half day, so they did a half day when we did a half day. So now they're doing a half day because of their end of the term, so we're doing it too.
Oh, I like this. Get more short days.
I don't know. So I mean, it's nice in some ways, bad in others.
Wait, it's not.
But what I'm saying,
I'm so confused.
So the little elementary kids, it's their term then, but it's not ours.
Okay.
but we're on the same schedule.
Okay. Yeah.
Okay, now with that though, what I want you to understand, give me attention here, is I understand that sometimes at the end of the term on that short day, like nothing happens in class, we will be learning a lesson that day. And luckily covalents are actually easy compared to ionics. So it's okay that it's shorter, but just recognize if you choose not to come, that you are going to have things you need to take care of on your own. So don't just think, oh, we're not doing anything because it's a shortened day. Also recognize that I'm here all day. So if you do need help with anything, Friday's a great day to come get help if you're needing help on any of this stuff, or if you're wanting to retake or do the Unit 3 tests, corrections. I'll be here throughout the whole day. So, okay. Let's jump into this. So we're going to kind of read it last time where we're going to put the rules down first, and then we'll just kind of apply them and practice it. Okay, so this should be at the beginning of your notes because we kind of skipped ahead last time. Now you should see the connection because we're just doing the reverse of what we did before. Okay, so just like before, the cation comes first, or the positive one we always name first. Just like in the formula, the positive one always comes first. Okay, now, can someone remind us from last time, what does a Roman numeral in a name tell me? Good, it tells me its charge. So if you're going in reverse, with an element whose charge is unknown, you have to bring the Roman numeral back into the name. Otherwise, you can't go back and forth because you don't know its charge. So the rule is that if it's in the S block, you don't have to do a Roman numeral because we always know their charges, right? This is always +1. These are always +2. Outside of this and 3 special ones, you have to include their charges. I mean their Roman numeral. Okay? I think the 3 special ones are on the other side. But keep in mind, I'm going to do some practice with that of what it means, okay? So these are the three that don't need a Roman numeral, but are outside of these two columns. Aluminum, zinc, and silver. So if one of these are in your formula, the name doesn't need a Roman numeral because they're always plus 2, plus 3, plus 2, plus 1. Once again, this would be something either you can memorize or like put down on my note card just to remind you. There is kind of a cool diagonal pattern like we pointed out last time. Plus 3, plus 2, plus 1 to kind of help you remember their charges. But
Where are we in our notes?
we are, where we left? On page 2.
Page 2.
Yeah, page 2.
Is that where it's at?
Right there. Ionic naming steps.
Thank you.
Okay, so first thing is the positive one. Second thing is the negative one. Now we have two different types of negative endings, or two different types of negative things. We have things that are just elements, and we talked about how those end in the ending of ID. Okay, so if it's just an element, you change the ending to I. Now sometimes it can be tricky to know how to change it, because it's kind of like you gotta drop some and add some. For now, if you mess that part up, like spelling-wise, I don't care. As long as you have the right element and the right ending, and I can see you're trying to put it together, you're good. You'll kind of figure out the spellings just the more that you practice it. For example, oxygen would become oxide. Phosphorus is kind of a weird one. Phosphorus becomes phosphide. You drop a little bit more on that one, but you'll kind of just figure it out as we go. Okay, so there's some examples. So chlorine would become chloride. Oxygen becomes oxide. Now, if it is a polyatomic, you don't change the ending. Okay, they already have their special names. So if it's one of the polyatomics, you just look on your chart, which is the last page of your notes. Right, this chart right here, and you just leave it as is. So you don't change them, just take it as it is. Now if you want to make a note, the way you can identify something as a polyatomic is you're going to have more than one capital letter. Because that means it's not an element, it's lots, it's multiple elements. Or the other way you can identify the polyatomic is if there's ever parentheses. It's a polyatomic for sure. But there won't always be parentheses, but this is always true. But if you have parentheses, you know for sure, oh, look on my chart, what is this thing's name? And just a reminder, you'll be able to use this chart when you take the test, and you don't have to squeeze it on your note card. Okay? Okay, let's talk about how we figure out what the Roman numeral is. So let's do a practice problem here. Okay, so here's my formula, FeCl3. We want to write this substance's name. So first step is to name the first thing. So what's Fe? Iron. Okay, so first step, name the metal. Second step, check where the metal is on the periodic table. Point with your finger, where's iron? Good. Do I know iron's charge by its position? No. So we've got to find what the Roman numeral is for the name. Okay, so what I like to do is if I found that, I just kind of draw a line to remind me, okay, this needs a Roman numeral. Okay? Cl is chlorine. When it bonds, it becomes chloride. Jackson, is this, so on the camera, there's like a bright dot.
Yeah.
Is this right on the bright dot? Or can you read it?
It's pretty much right on the bright.
Is it? Okay, I always forget because I can't see it, but it like makes horrible for them. Okay, we're right. Okay. Okay. So the Roman numeral is the charge of the metal. The charges have been balanced in the formula. So what we have to do is kind of think backwards and reverse the balancing. So go to the periodic table. Based on the periodic table, what is chlorine's charge? Chlorine has a -1 charge. Yep. Everyone remember how to find charges? Do we need a review of that? So charges, Rachel, how do you know it was -1?
Because it was in, not the very last column, but it has 7 external electrons.
Good, so you go by its valence electrons, so I had 7 valence electrons, and then the charge is what is it going to do to either get full or get empty. And in this case, it wants 1 more, so that's why it's -1. You can also count the up and down, so it goes +1, +2, +3. Skip the middle, -3, -2, -1. So it kind of climbs up and then climbs down. It's another pattern you can kind of follow. Okay, so we know that its charge is a -1. The second thing you look at is how many you have. So we have 2 chlorines, each with a -1. So that means this side of the molecule is a -2 total. Because 2 times -1 is -2. Which means this side has to balance out
And have 2.
and be +2. Sorry, that marker is not working like I want it to. Okay, so this side needs to be +2, and you only have 1 of them. That's what the Roman numeral is. So the name of this compound is iron 2 chloride. Okay, if you want to draw a little arrow here, the Roman numeral is the positive charge. We'll do another practice here, but any questions right now? Yeah.
How did you get the charge again?
Which, this one?
Yeah.
So you go to the thing that's negative, and we found its charge first. We then did the total, so there's 2 of them. So it's -2, and the charges have to add up to 0 just like before. So if this side is a -2, then this side has to be positive 2.
Okay.
And we'll do another practice here in a
Alright.
second. So, any other general questions right now? Now this is just a format thing. The way I learned it, I don't put them in parentheses. I just write the Roman numeral. But some people write the Roman numeral in parentheses. But that's your choice. I don't. Some people do.
And you have to write it as a Roman numeral?
But it does need to be as a Roman numeral, yeah. But the highest you're going to get is 4. So it's not yet, but like 2 tenths of Roman numerals. Okay, let's do some practice problems here. They're like 2 of them. Oh, there they are.
Yeah, just leave this.
Okay, let's start with okay, so let's do this one as an example, okay? So I'm gonna write the rules again, but like in a very simplified way. This is what my brain does to solve this problem, okay? So step 1 is name the metal. Perfect. Okay, so step 1, name the metal. Iron. Step 2, check for Roman numeral, because sometimes you will need them. I need it for iron? You kind of just did it, so yes, it is needed. The way you know is by looking at where it's at on the periodic table. Okay? Step 3 is name the non-metal or polyatomic. If it's a non-metal, then you change it to I. So in this case, it's sulfur. So when it bonds with things, it's going to become sulfide. Last step is we balance the Roman numeral. Okay? So, to balance the Roman numeral, you go to what it's with first. So find sulfur on the periodic table. Don't say it out loud, but show me on your fingers what is the charge of sulfur. Don't say it out loud, just show me on your fingers what is the charge of sulfur. Here, if you're showing me -2 or 2, you can have a smiley face if you're correct. Okay, so these are just to remind us, these are the steps to find the Roman numeral. Okay, step 1 is you find the negative charge. Okay. Step 2 is you multiply it by the total number of negative beams. Or by what is called the subscript. So in this case, I'm going to take 2 and times it by 3, and I'll get
-6.
-6.
I just thought the highest you'd go is 4.
Hang on, it will. The
Oh.
Roman numeral won't get higher than 4. Okay, so what does that tell me about the positive side?
It's 6.
So the total of the positive side is 6. But this time, how many positive things do I have?
2.
So now you take the positive charge divided by those to get a charge of +3.
What, you're dividing it by 2 because...
There's 2 of them. So this number outside is the positive total, right? And so we have 2 of them, and so that's how much. You can also look at it this way if you want, like visually. So sulfur, I have 3 of them. So I'm going to draw 3 S's each with a -2. I have 2 Fe's. Okay, these 2 need to add up to 6 because these ones added up to 6. And so the only way that works is if these are sulfurs. So sometimes if that helps you kind of draw it out more, you can do it that way. But that tells me the Roman numeral. So the name of this one is iron 3 sulfide. And finding the Roman numeral is the trickiest part of ionic chemistry. Any other questions on that for now? Okay, let's do a few more practice, and then I'll have you practice some on your own for some smileys. Okay, so our last step was to multiply a subscript, and then we had to balance the positive side. Okay, let's name this guy. So Na is?
Sodium.
Good. Step 1, check. We named the metal. Step 2, do I know sodium's charge from its location on the periodic table?
Yes.
So we don't need a Roman numeral.
Oh, yes.
Okay, so then we skip to step 3. Br is
Bromine.
bromine. It becomes bromine. Sodium bromide, and you're done.
Brilliant. we put a 1 on for sodium or no?
Why do I not have it?
Because we already know it's charged.
Yep, it's only because, so in this case, iron was a 3, in the other case, it was a 2 because it can vary. If it doesn't ever change, we don't have to list it, because
Okay.
we don't need it.
Okay.
Great question, though. Okay, coming over here, Na is?
Sodium.
Sodium again.
Yeah.
Does sodium need a Roman numeral?
No.
Nope, so we skip step 2. Now, the second half is 2 capital letters, which means don't look it up here on our table, look. There you go.
On the polyatomic chart. Yeah.
Find the thing that is CO3 and its name is carbonate. Sodium carbonate is its name. Yeah. Questions on that one? That's it, yep.
We don't have to change the name. Yeah.
Yeah, so you don't change the ending, you just pretty much are naming the 2 halves. It's like first name, last name, and that's it. Yeah, Melody.
So even though the subscripts are different, we just ignore them?
Yes. The reason being is if you think of going in reverse, okay, like if I've given this and I'm writing that, these can be determined through what they are by looking at their charges on your table or on your polyatomic chart, and so it's not necessary to include anything with the name, numbers in the name. So, great observation though. Okay, let's do one more together here, everybody, and then I'll stop talking unless you want my help. Okay? All right, Fe is?
Iron.
Iron again. Does iron need a Roman numeral?
Yeah.
Definitely. So leave a spot there. The second half is CO3, which name is? Carbonate. So it's iron something carbonate.
What about
We don't even have to, well, we will in balancing the charges, but in terms of the name, it didn't matter.
Okay.
Okay, so to find the Roman numeral, step 1 is we gotta know the negative charge. So what charge does carbonate have when you look at your chart? Negative. Okay, so we have a 2 minus for carbonate. Okay, we then multiply by the subscript to get a total of negative 6. Okay, so notice that I'm timesing what's outside the parentheses, not inside. Okay, that means that the positive side needs to add up to plus 6 as well. So 6 divided by 2
is 3.
gives me a 3 again. Iron 3 carbonate. Questions on naming thus far? Okay, I would like you to do the remaining 4 practice problems with your table buddies or by yourself. Once you think you have it, I'll come check it out for some smiley faces. Once you've earned your smiley faces, then you have the green light to get started on the homework, which is the back side of what we did last time. Another note on the homework, most of you did this, but some of you did not. So I've left it open until tomorrow. There is a little quiz on Canvas called Ionic Compounds that you all can do. Some of you already did this, so if you did it, you don't do it again. Because it was assigned last time. But I've left it open through tomorrow if you did it. Okay? Okay, try those last 4. Once you think you've got it, raise your hand and we'll come see how we did.
So I got nickel carbonate.
Wait, we don't know the charge.